Hello students, welcome to Smart Learning Science class. I am Neha Kapoor, your science teacher.
टेल मी, जो चीजें हम देख सकते हैं या फील कर सकते हैं वो सब क्या होती हैं? मैटर।
मैटर 3 स्टेट्स में होता है, सॉलिड, लिक्विड और गैस। सॉलिड पार्टिकल्स क्लोजली पैक्ड, लिक्विड थोड़े दूर और गैस पार्टिकल्स बिल्कुल ही फ्री।
So children, are you ready for more science magic? To bolo ko hai? Yes, ma'am.
आज हम मैटर के कॉन्सेप्ट्स को फन वे में समझेंगे।
Have you ever just looked around and wondered what everything is really made of? I mean, from the air you're breathing right now to the screen you're looking at? Well, today we're going to peel back the layers of our ordinary world to find the extraordinary science that's hiding inside. Okay, let's just dive right in.
So think about this. It's like a little magic trick you do every day. You take a spoonful of sugar, you stir it into a glass of water, and poof, it's gone. But did it really vanish? Or did it just go somewhere we can't see? This little puzzle is actually the key to understanding, well, pretty much everything.
So to solve our sugar mystery, we've got to ask an even bigger question first. What is everything actually made of? We're about to uncover a world that is completely invisible to our eyes.
So the official sciencey name for all this stuff is matter. And the rule is simple. If it has mass and it takes up space, it's matter. That covers everything, from the stars in the sky to a single drop of water.
And here it is, the first big secret. Everything, the water, the sugar, even you, is made of zillions of tiny, tiny particles. They are so small, it's almost impossible to even picture. So reality isn't one solid, continuous thing. It's a giant collection of individual little bits.
And that brings us back to the sugar. It didn't just disappear. What happened was its tiny particles broke apart and slotted themselves into the empty spaces that were already there, right between the water particles. It's kind of like pouring sand into a jar of marbles. The sand just fills in all the gaps. Mystery solved.
Okay, so we've got that matter is made of tiny particles, and there's space between them. But there's another secret these particles are hiding. They never, ever, ever stop moving.
Here's another puzzle for you. You know how the smell of hot, sizzling food seems to find you from across the room? But for cold food, you pretty much have to stick your nose right in it. This isn't just about the food. It's about the crazy, non-stop dance of particles in the air. What's happening is that all these particles are constantly jiggling around. They have what scientists call kinetic energy. Now, when you heat them up, like with sizzling food, you're basically giving them a huge energy drink. They start moving way, way faster. These speedy smell particles spread out and mix with the air really fast, and that process is called diffusion. So, hotter food just means faster diffusion.
So these particles can be packed together really tight, or they can be flying all over the place. And this difference in their behavior gives matter its 3 main personalities, or as we call them in science, its 3 states: solid, liquid, and gas.
You can see the big differences right here. In a solid, particles are basically locked in place by a really strong attraction. They can only vibrate. In a liquid, those bonds are a bit weaker, so the particles can slide past each other. And a gas? It's a total free-for-all. The attraction is super weak and the particles are just zooming around randomly at high speeds. That's why a gas will always fill up whatever container you put it in.
And this visual just makes it crystal clear, right? Look at that neat, ordered structure of the solid. Then the looser, flowing arrangement of the liquid. And then just the total chaos of the gas. It really is all about how much energy those particles have and how tightly they're holding on to each other.
So if particles can act so differently, it makes sense that they can change how they act. But how does a solid actually become a liquid? It's not just about getting hotter. There's actually a kind of hidden energy that makes it happen.
Okay, now think about this one for a second, because it sounds totally impossible. How can 2 things at the very same temperature cause a completely different amount of damage? Well, the answer is all about that hidden energy.
This hidden power has a name: latent heat. When you're melting ice, for example, the temperature stays stuck at 0 degrees Celsius until every last bit of ice is gone. All the heat you're adding isn't making the water hotter, it's being used to do a job, to break the bonds holding the particles in that rigid solid structure. That energy is now latent or hidden inside the water.
And that is the exact answer to our question. To turn 100-degree water into 100-degree steam, you have to pump in a ton of extra energy, the latent heat of vaporization. So every single particle of steam is carrying way more of this hidden energy than a particle of boiling water. And it's that extra energy that causes a much more severe burn.
This here shows the whole cycle. You add energy, you move up the ladder, from solid to liquid to gas. You take energy away, you go back down. And some materials can even do this cool trick where they jump straight from a solid to a gas. That's called sublimation.
All right, let's wrap this up with one of the most useful, practical processes in our everyday lives. One that literally keeps us from overheat. We've all felt this, right? That sudden, intense cold feeling when you use hand sanitizer or when you first step out of a swimming pool? That's not just the liquid being cold. That is an active cooling process happening right there on your skin. The process is called evaporation. Now, unlike boiling, which happens all through a liquid at one specific temperature, evaporation only happens at the surface, and it can happen at pretty much any temperature.
So here's the really important part. The most energetic particles right at the surface of the liquid actually suck up heat from their surroundings, in this case your skin, to get enough power to break free and escape as a gas. And when they leave and take that heat with them, the surface they left behind feels cooler.
This is exactly why we sweat. It's our body's built-in cooling system, and it's why wearing cotton in the summer is such a good idea. Our body makes sweat, and as that sweat evaporates, it pulls heat away from our skin, cooling us down. Cotton is just fantastic at this because it absorbs the sweat and spreads it out over a larger area, which means it can evaporate even faster and more efficiently. It's like having your own personal air conditioner. So, we've seen how temperature and pressure are basically the puppet masters of matter here on Earth, deciding if something's a solid, a liquid, or a gas. But it kind of leaves you with one last big thought. What other bizarre, incredible states of matter, like plasma or things called Bose-Einstein condensates, might be forged out there in the unbelievable pressures and temperatures of stars and deep space? The science of our everyday world is really just the beginning.
तो बच्चों, कैसी रही आज की हमारी क्लास?
And if you like the video class, don't forget to like, subscribe, and share.